Hi everyone, in this video I'll show you how to build a smart gate using Arduino Uno.
Before that, if you're interested, I offer full stack web development services on Fiverr. This is my profile link that I've also added in the description box below. Without further delay, let's get started.
So as you can see, this is my Arduino Uno, and then I'm going to use a breadboard, and then I also have with me is a servo motor that I'm going to use to operate the gate, ultrasonic sensor because I need to sense if a car is coming from inside the gate, and obviously a keypad membrane to input a code if a car is coming from outside to enter inside the building. And also I do need some LED lights because I need to know if the code that I input is correct or wrong. Alright, so these jumper wires are male and female, and these are just regular jumper wires. So I'm going to now connect this keypad membrane to the Arduino Uno. So I can do it directly using the jumper wires, but I'm going to take the help of these jumper wires just to extend it, and that way it's just for my own convenience that I can operate it properly. Okay, let's just connect it. So the row 1, it starts from here, so this is the one, and then starting from here, this has to be connected to the pin number 9, and as you can see, pin number 9. And as I was saying, the second row, which is this one, this has to be connected to the next pin number, which is 8. And like this, you go on. As you can see, I'm connecting this one first. And then this one goes to pin number 9. Next, the wire colors don't matter, it's just for my convenience. I'm just using, like, you know, blue with blue and all this, so you don't have to panic. And this is the second row, which is this one, and this one goes to the next pin number, which is 8. And in this way you connect the rest of them till 2. So as you can see, I have connected my keypad membrane to my Arduino Uno following the sequence, and I've also taped it to the table. It's just to reduce movement, and it's also because it's my personal preference. Anyways, now before I proceed to the next steps, I must mention some functions of a breadboard, more like how a breadboard works. So if you already know, you can just forward this part, else you can just stay around and listen. So as you already know, a breadboard has 2 parts. One is the power rail, which is this, and these 2 areas are the circuit area. Power rail, circuit area. So in case of a power rail, what happens is that if you connect something here, this entire thing sideways gets the connection. Same goes for here. If you connect something here, this entire thing gets a connection. As for the circuit area, if you plug in something here, then the thing that gets the connection is the holes that are at the bottom in this case. So if I say this is a part of a component that I linked here, so if I connect something here, I won't get the connection. Just to make the connection, I need to connect with here, anything that's in this area, like an up and down, like this, or here, or here. So it's just in this area. Basically, if you get like confused, it's fine. I've also provided a diagram for you to look at. All right, so now I'm going to connect this with Arduino. First, I'm going to connect the 5-volt, as you can see. And this 5-volt goes to the positive part of the power rail. So now this entire power rail is 5-volt. Now I'm going to connect the ground, which is this one. And then I'm going to connect with the ground of the Arduino. You see there are 2 ground, so it doesn't matter, any one is fine. So in this case, I'm just going to connect here. All right, and now I'm going to move on to the next step. So yeah, this is just how I just connected the breadboard to the Arduino by connecting the 5-volt and the ground, so that the other components that needs the 5-volt and the ground connection can be connected throughout this power rail. Okay, so now I'm going to connect the ultrasonic sensor. Ultrasonic sensor, if you look carefully, has 4 parts. One is the VCC, trig, echo, and ground. So I'm just going to explain in briefly, maybe because you might not be able to see how I connect the pins because of my fingers. So let me just mention some things. So the VCC, that will be linked to the 5-volt, and ground is ground, you obviously know. Trig, in this case, I'm going to connect it with the Arduino pin 11, and the echo, I'm going to link this to the Arduino pin 12. And the reason why I chose Arduino pin 11 and 12, because how I coded this, it's just accordingly that I'm going to make sure that trig and echo are linked to the Arduino pin, specifically 11 and 12. But if you want, if you can like link to any Arduino pin that are like available, and accordingly that you need to code. So do make sure that you do not put this in a different Arduino pin, like say you put trig in Arduino pin 13, but you in your code put Arduino pin 11. So do not do that. Okay, so I'm going to connect this to the breadboard. Again, as I said earlier, breadboard makes it very easier to connect a lot of components together. So this first part is the VCC, which is the 5-volt. The next one is the trig, and the next one is the echo. This part, this entire circuit area, is the ground. So let's connect. So the VCC is this one. They're also labeled at the back, so don't get tense like you have to move this, and because this is the only part that's labeled. No, they're labeled everywhere. So I'm going to follow the circuit area and link this to the 5-volt, which in this case is this part of the power rail, as I mentioned earlier. And now this is the ground. So let me just, the pin doesn't matter like where you want to pin, as long as you ensure that you're in the correct correction area. So here, let me just check. Yeah, this is the ground. So yeah, this is my ground area, and I'm going to link this to the ground part of the breadboard, just like that. And now I'm going to link the trig, which is here, as you can see, the second one. And this is my echo. It's getting congested, so I'm gonna put it here. I mean, that's the beauty of the circuit area. So when you make a connection, this entire thing gets it. So it doesn't matter where you put the pin as long as you plug it in correctly. So the blue one is the trig that goes to pin number 11. Again, as I said, I coded accordingly like that. So that's why I'm going to choose pin number 11 for this. And my echo, which is this one, I'm going to put this in pin number 12, which is next to it. So the trig went to pin number 11, echo went to pin number 12. Alright, so that's how I connected the ultrasonic sensor. Moving on. Okay, now I'm going to connect the servo motor. So I also like to mention that in my project, I use the servo motor that has one arm. There are other servo motors that has two arms, which is one here, just like a helicopter propeller. So it depends on what type of project you're using. It's kind of based on that, how you'd like to use the servo motor. And yeah, and now I'm also need to mention some things about the wire. Servo motor has 3 types of wire. I believe this is orange, red, and brown. So the orange wire goes to the Arduino. The red one is the one that needs to be connected to the power supply. In this case, that's the 5-volt. And finally, the brown one that goes to the ground. All right, let's begin. So let me get a jumper wire. Oops. So let me choose the red. Now let me go with the orange one, because the orange one has to be connected to the Arduino pin, and I need a longer jumper wire. So here in this case, I'm going to connect the orange one with the Arduino pin 10. As you can see, that's right here. Okay, and now I'm going to connect the rest of them accordingly. So this is my, this one is the red one, and I'm going to link this to the 5-volt power rail. And finally, the ground, which is the brown colored, I'm going to connect that with the negative power rail. And the way I'm going to position is going to be something like this. So this, the arm of the servo motor is at 0 degree currently. And as soon as a car wants to, like, you know, cross through, the gate has to open, and for that I want it to rotate positive 90 degree that I put in my code. So it's going to rotate like something like this, like this is going to rotate up 90 degree. That's how the gate opens and the car enters. So that's how I programmed it, and that's the reason why I'm going to use one arm, because I just need this one to open the gate, not the other one. Okay. Now I'm going to connect the LEDs, which in this case is the red and green LED, because I want to at least ensure that the user input the correct password or the wrong password, or if the password is too long, or is it, you know, and all those stuffs. And also make sure you use resistors for your LED. And it's really important that you use resistors, and you need to use resistors when you're using LED because you do not want to overcharge the LED and that will blow up. And in my case, I'm going to use 220 ohm resistors, and that's a pretty decent amount, and it will be enough to block huge amounts of current. And obviously some jumper wires. Okay, let's get started. LED has two legs. One is a long leg, which is the what do you call it, the anode part, and the shorter leg, that's the cathode. And the cathode has to be connected to the ground, and the connection that has to be come from, which is the Arduino pin to signal that it's correct, light up the green light. This is the one that has to be first linked with the resistor for the current to pass through. Okay, so let's begin. Just remember where you're putting. So I'm putting the long leg here, anode goes here, and the short leg, which is the cathode, here. So this circuit area. Now I'm going to use the resistor. I'm going to connect this circuit area with this circuit area, to expand and make room. It really doesn't matter how you want to put it. It's just, this is my personal preference. So this is the long leg that needs to be linked with the resistor first. Okay, let me just check. Long leg here. Yep, there is here, current is flowing through here. So in this circuit area, I have to connect another jumper wire to the Arduino. I guess I've used all the areas, so it needs to be here. I'm using a series connection, so the current's gonna flow here through the resistor, through the LED light. Okay, so since this is my green LED, I'm going to connect this with pin number 13 of the Arduino. Pin number 13 is right here, if you can see. Let me connect it back. Okay, now I'm going to use the same technique to connect the red one. This is the long leg, this is the short part of the leg. Resistor, make sure you're plugging into the correct pinhole, the correct circuit area. Okay, this is the circuit area. I'm gonna plug this in this pinhole, and since I've used all this pin, I'm going to use another pin, which is A0. Let me just put this in and I'll show you. This is the one that I put it in A0. And now let's complete the connection. So this is the short arm. Let me put this in this pinhole, and this needs to be linked back to the ground. Same goes for the red one. Now following the short leg, put it in this pinhole. Yeah, this is the right one, and then complete the connection, connecting it with the ground. Alright, so that's how I connected my LEDs, and yep, this is how my project is supposed to look like for the smart gate. This is the pin, and when the car is trying to enter the building from outside, they need to enter the pin number. If it's correct, the Arduino will signal for the green light to turn on. If it's incorrect, red will turn on. And if it's correct, not only the green will turn on, the servo motor will also rotate, and the gate is gonna open, the car is gonna enter. And if any car is exiting from outside, from inside the building to outside, the ultrasonic sensor is just gonna sense the presence of a car, and then it'll just open the gate and the car will just exit. So when you're exiting, there's no restrictions. It's just when you're entering, there are restrictions. So yeah. And now my one final thing I'm going to do is obviously connect my project with my laptop. So I'm going to use this cable. This one goes to laptop, obviously. And then if I connect it, you see it lights up. That means the connection is accurate and everything is okay for now.
As you can see, this is my Arduino IDE platform, and this is the serial monitor. This is the area where I put the code. So you can see that the ultrasonic sensor calculating the distance. The reason why it's showing up because I put serial.print. That helps me to at least keep in track of how much distance the ultrasonic is calculating, and to detect whether there is any car present. And it's a very good idea to use it. So in this way you can also see at the back end like what's happening. And you can also see if the keypad is working. If I press asterisk, you see if I press 8, 9, 5, 4, 9 again, and you see it says incorrect and there was a delay. So that kind of means that my keypad is working and I'm good to go. And if you code it and the code is not connected with Arduino right away, the only best you can do is to upload it again, as you can see right here. And I connected the Arduino with my laptop through here. Here you can see it's already linked. Let me show you. Just select other board and port. Here my platform is Arduino Uno, so I'm going to search Arduino Uno UNO. As you can see, there's a check mark. That means it's already connected, and this is the port, and there's also a check mark, which kind of means it's already linked. And okay, so that's how you connect your Arduino with your platform, the Arduino IDE platform. And this is the backend part, like what's happening. And yeah, that's pretty much it. Now let me show you the demonstration.
Okay, so I have put a screen at the corner, as you can see what happens at the back end. I've just put the serial monitor part, so at least you can keep a track of what's going on. Okay, so let's go ahead. Say suppose a car is trying to enter the building. So let's see if I enter the password, it takes it. Star 1, 2, 3, 4, 5. So the green light is light up and the motor moved. So let's just focusing on the motor, covering the green light, because in case if you have missed it. Star 1, 2, 3, 4, 5, 5. You see the motor is moving 90 degrees above, so that kind of means that the password is taking and it's checking and it's seeing if it's correct, and if it's correct, then that's how it's working. And if a car is trying to like exit from inside the building, and it obviously have to go through the ultrasonic sensor, and you see it moved, and it's going to stay open as long as there's a car. Once it passed, it's going to close. And now if there's any, say suppose someone has put a very long password, it should come out as incorrect. See, the red light flashes, and say suppose someone put an incorrect password. The red light flashes. So as you can see, the code is working perfectly, and yeah, that's how I was able to come up with this idea to build a smart gate that we can use it for our just a security thing for our apartment complex or even our own houses. So yeah, it's just a prototype of that.
As you can see, this is the type of box I used, and that's the box size. And this is basically my personal preference. There is no hard and fast rule that you have to use a box of this size. It's totally up to you. As you can see, this part of the keypad membrane is folded and taped to this wooden phone stand. The wires go through this charger hole all the way connected to the Arduino Uno. The USB cable connected to this Arduino board goes behind the phone stand and out through this hole at the back. This way I can easily plug it into my laptop. To prevent excess movement, I taped my breadboard to the base of my box. I placed the servo motor here, the arm facing in this direction. If I put my finger, as you can see, the motor moves. This is my cardboard gate that I prepped in advance. This is a barbecue stick that I broke into two, wrapped it around in a paper and taped it to this board. Let me now fasten this to the arm of my servo motor, gently shoving it in, just zooming in a bit so you can see how I attached it. And this is how it should look like.